Now, I have this simple phrase that you can always remember. And, you know, we all like fried chicken. So think of Kentucky Fried Chicken. And the mantra here is keep, factor, cancel. Hence KFC. So what does it mean? You can either keep the numerator and denominator as is, that is, if you're not able to factor, or factor it. And if you factor it, there is a possibility that you can cancel some terms between the numerator and the denominator. So I look at the function f of x. There is no need for me to keep it as is because I see a bunch of x's that could be factored out. So I move on to the next step. I pull x out, which is the factoring step. I have 8 minus 5x in the numerator. If I pull x squared out, because I have x cubed and x squared, I'll simply have x minus 1. The x and the x squared will get cancelled. So we simply have 8 minus 5x divided by x times x minus 1. We have 4x squared divided by 8x minus 2x squared. You can keep them as is, the numerator and the denominator. But if you look at the numerator, there is a 4, denominator, we have 8 and 2. So there is a possibility for us to factor. So I'm going to move to the next step, which is factoring. Numerator, nothing to factor there, so I'm going to keep as is. Denominator, there is a 2, there is an x, that's in common. So if I pull 2x out, I would simply have 4 minus, I get 2x out, so that would leave me with x. Now you can see that there is a 2 that can be cancelled out. There is an x that can be cancelled out. So we would end up having 2x divided by 4 minus x. So should we keep the numerator and denominator as is? No, because we see a whole bunch of x's that are in common. So I'm going to keep the numerator as is. And in the denominator, I see that x squared is common to all 3 terms. So if I pull x squared out, I'll have 3x squared minus x plus 1. And between the numerator and the denominator, we have an x squared in common. So that will get cancelled. So we will have x over 3x squared minus x plus 1. So first, should we keep the numerator and the denominator as is? Well, the denominator must be kept as is because there isn't much I could do with x plus 10. The numerator, we have to see if we can factor. If we can't factor, we will still leave it as is. So the numerator can be factored. So we have a negative 40. We've got to come up with two numbers so that I get positive 6x. So I could write it as 10 times negative 4. Now I can factor the numerator. X squared plus 10x minus, 4x minus 40, which would be x. I have an x in common between the first two terms. If I pull that out, I'll have x plus 10. I have a negative 4 in common in the last two terms. If I pull that out, I would have x plus 10. I have an x plus 10 in common. If I pull that out, I will have x plus 10 times x minus 4. So the numerator will be x plus 10 times x minus 4. That is the factored form. Now I divide it by x plus 10. Now it seems like we've got a common factor, x plus 10. So I can cancel that, which will leave me with x minus 4. So what looked like an intimidating rational expression simply reduced to x minus 4. So now we have a polynomial divided by a polynomial. So if we're not able to factor the numerator or the denominator, we will keep it as is. But if we can factor, we need to proceed with factoring. Let's see if we can factor the numerator. We have 2x squared minus 7x plus 4. 2 times 4 is 8. So I've got to split up 8 in some way so that I get negative, So I've got to split up negative 7 in some way so that I get the 8. That'll be formed using 2 and 4, 2 times 4. So what are the possible ways? I could try negative 7 times positive 1. That would give me negative 1. Or that can be negative 7 plus 1, which would give me negative 6. Negative 7 minus 1 would give me negative 8. But what we have is positive 8. So the other possibility would be negative 7 times negative 1. That will give us a positive bad mistake there. Negative 8 times I'm factoring the wrong thing. So we have 8, and we can either write it as 8 times 1, which would give us 8. I could write it as 2 times 4. That would give us 8. What other possibilities do we have? Well, I could do 10 times 2. Excuse me, I could have 10 minus 2. But 10 times 2 is not going to give me 8. So it seems like that's not going to work. That's not going to work. That leaves us with very few options or no options at all. So there is no way I can split that A directly. But if I change that to x squared, oh, it looks like the original problem had a minus. So yeah, this particular one cannot be factored. That's exactly where I was going to conclude that it cannot be factored. The original problem actually has 2x squared minus 7x minus 4. So my troubles are over. Minus 8, which I could write it as minus 8 times 1, or 1 times minus, excuse me, negative 1 times 8. If I add negative 1 and 8, I am going to get positive 7. That's not going to work. But negative 8 times 1, when I add negative 8 and 1, I am going to get negative 7. So I could write 2x squared minus 7x minus 4 as 2x squared minus 8x plus x minus 4. I have 2x in common between the first two terms. If I pull that out, I will have x minus 4. I have a 1 in common. If I pull that out, I will have x minus 4. X minus 4 is in common. If I pull that out, I would end up having x minus 4 times 2x plus 1. So we have successfully factored the numerator. Let's see if we're able to do that with the denominator. X squared minus 5x plus 4. So we want to split 4 into its factors. So we have 4 times 1, or negative 4 times negative 1. If I add 4 and 1 directly, I will get 5. If I subtract, I'd get 3. So the first one is not an option. But the second one, negative 4, negative 1, if I add, I'd get negative 5. So I could write x squared minus negative 5x plus 4 as x squared minus 4x minus x plus 4. In the first two terms, I have x. So I will have x times x minus 4 minus 1 x minus 4. We have x minus 4 in common. If I pull that out, I have x minus 1 times x minus 4. So I was able to successfully factor the numerator, successfully factor the denominator. Now we end up having x minus 4 times 2x plus 1 divided by x minus 4 times x minus 1. Clearly, we can cancel out x minus 4. Which will leave us with 2x plus 1 divided by x minus 1. Any questions? So should we keep the function as is, or should we try to reduce it by factoring and then cancelling? We'll start with the numerator. So we have 10 times 3, which is 30. I want to split 30 up into 2 terms so that I get negative 11. Negative 6 times negative 5 is the best candidate, or the only candidate. So that is going to work. So I am going to split the negative 11x as negative 6x, negative 5x. In the first two terms, I have a 3x in common. If I pull that out, I would have x minus 2. In the last two terms, I have negative 5. And if I pull that out, I would have x minus 2. So x minus 2 is in common. So x minus 2 times 3x minus 5. That is the factored form of the numerator. Now I could factor the denominator, if at all possible. So I have x squared minus 7x plus 10. So I have 10. I need to split it into two numbers so that I get negative 7. So the candidate here is negative 5 times negative 2. X squared minus 5x minus 2x plus 10. We have an x in common in the first two terms. So if I pull that out, I would have x times x minus 5. We have negative 2 in common in the last two terms. If I pull that out, I would have x minus 5. X minus 5 is now in common. If I pull that out, I would simply have x minus 5 times x minus 2. So I could rewrite the numerator as x minus 5 times x minus 2. I could write the denominator, backwards. The numerator, x minus 2 times 3x minus 5. The denominator, x minus 5 times x minus 2. The x minus 2's will get cancelled. We will have 3x minus 5 divided by x minus 5. So should we keep the denominator as is? Yes, there is nothing I could do about it yet. The numerator is x squared minus 25. X squared minus 25, I can rewrite it as x squared minus 5 squared. That is a special product. So I could write it as x plus 5 times x minus 5 divided by 5 minus x. Is the cancelling step going to work? Well, it looks like we can cancel x minus 5 and 5 minus x. But how though? Well, if I pull a negative out of the denominator, I will end up getting x minus 5. So the numerator and the denominator x minus 5 will get cancelled. So we would simply have x plus 5 divided by negative 1, which is minus 1 times x plus 5.